Alright, welcome back. This is lesson 2 of Surf School. Now we're talking operations with radicals. Operations is just addition, subtraction, multiplication, or division. Let's get going with that. Start thinking. Like we talked about last lesson, there's a lot of similarities between fractions and radicals. So I want you to tell me, what are the rules for adding fractions and what are the rules for multiplying? Pause the video here. Make sure you actually remember these as well. Okay, so adding fractions. Remember, you needed like denominators, and then you added the numerators and left the denominators alone. And for multiplying, what did we do? For multiplying, you multiplied the numerators together and you multiplied the denominators together. Alright, so let's start with how do we add and subtract radicals? How do we add and subtract radicals? Well, with fractions, like we said, first of all, we need a common denominator. Then we added the numerators, left the denominator alone. Let's look at what the rules for radicals look like. When we're adding or subtracting radicals, what do? Well, we need a common radical, or we need like radicals. So we need the numbers inside of the radicals to be the same. Then what do? We add the coefficients, and we leave the radicals alone. So just mess with the coefficients, leave the radicals alone. Let's go through a couple of examples. How do we add 3 root 2 plus 4 root 2 together? Well, they have like radicals, so we're good to go. We add the coefficients, 3 plus 4 gives us 7, and we leave the radical alone. Subtracting, same sort of thing. If we have 11 root 3 minus 6 root 3, what are we going to do? Well, coefficients go together. 11 minus 6 gives us 5. Leave the radical alone. One more. Let's say you have 2 root 3 plus 5 root 7. Right, how do we add or subtract these? Well, we need like radicals. Are the numbers inside the radicals the same? They are not. These two are not like, meaning that we can't simplify this. That is our answer, 2 root 3 plus 5 root 7. Alright, so that's adding and subtracting at the most basic. Let's talk about what happens if we don't have a like radical. Let's think back to fractions again. What did we do when we were adding and we didn't have like denominators? Well, we needed to get the common denominator. Right, we multiplied both sides until we ended up with the same number on the top and bottom. With radicals, we're going to do the same thing. We're going to simplify the radicals. Or we're going to get new radicals that are hopefully alike. So let's say you're looking at something like 10 square root 3 plus 2 square root 12. Now you'll notice 3 and 12 are not the same. Let's try factoring, or let's try simplifying square root 12 though. We can divide that by 2 to get 6, by 2 to get 3, and by 3 to get 1. So we can pull a set of 2's out from this. This becomes 10 square root 3 plus 2 times 2, 4 square root 3. And hey, would you look at that? We have like radicals, meaning we can combine these. Coefficients get added, radicals stay the same. So 10 plus 4 gives us 14 root 3. All right, let's look at a harder version of this. Let's say you have 3 square root 8 plus 5 root 18. Now we have 2 of these, and it looks like they both can be simplified. So let's start with 8. What do we get? Well, we divide by 2 to get 4, 2 to get 2, and 2 to get 1. So this becomes 3 times 2, or 6 root 2. What about 18? Going to do the same thing. We divide by 2, we're left with 9. So we divide by 3 to get 3, and 3 to get 1. We have those 2 3's, so those get pulled out. So this is 6 root 2 plus 5 times 3, or 15 root 2. And once again, what do you look at that? We have 2 numbers that are the same inside the radical. So we just add the coefficients together, making this 21 root 2. So that's how we add. Got to make sure you have like denominators or like radicals. Then we're going to add or subtract the coefficients and leave the denominator or the radical alone. What about with multiplying? Let's again look at fractions. What did we do to multiply fractions? Well, we multiplied the numerators and we multiplied the denominators. So for fractions, we multiplied the tops together, we multiplied the bottoms together. Radicals are very similar. With radicals or square roots, we're going to multiply the coefficients together, or the numbers outside of the radical, and we're going to multiply the numbers inside the radicals together. So multiply the outsides together and multiply the insides together. All right, let's look at some examples of that. If you have 3 square root 2 times 4 square root 3 plus 5 square root 2. First thing we're going to do is we have to distribute this in, right? Think of this as just a number or some variable. If this were x, what would we do? We'd distribute it into both terms. And that's what we're going to do here. So we're going to have 3 square root 2 times 4 square root 3 plus 3 square root 2 times 5 square root 2. And what do we do from here? We multiply the coefficients, and then we multiply the radicals. So 3 times 4 gives us 12. Square root of 2 times 3 is 6. Plus 3 times 5 is 15. Square root of 2 times 2 is 4. Now be careful here, because it looks like we're done, but what's the square root of 4? Well, that's just 2. So the correct answer for this is 12 square root 6 plus 15 times 2, or 30. Let's clear up that 6. Square root 6 plus 30. All right, one harder one here as well. Let's say you have 2 plus the square root of 6, problem 2, problem 1, times 3 minus the square root of 2. Now we have multiple things. What did we do when we were looking at something similar to this previously? This looks very similar to if we had something like x plus 2 times x minus 3. So what did we do then? Well, we FOILed. And that's what we're going to do here. We're going to take the first times the first, the outsides, the insides, and then the last. So this becomes 2 times 3 gives us 6. 2 times negative square root of 2 is minus 2 root 2. Square root of 6 times 3 is plus 3 square root 6 minus, we have these two together, so 6 times 2 gives us square root of 12. So again, we have to be careful here. This looks finished, but got to make sure 12 is correct. We can pull out a 2 to make this 6, 2 to make that 3, and a 3 to make that 1. So this is actually 6 minus 2 root 2 plus 3 root 6 minus 2 root 3. So when we're dealing with radicals, treat it the same way as if we were looking at variables. If we need to multiply together, we can FOIL, we can distribute, and then our coefficients get multiplied together and our radicals get multiplied together. Now we have just one more topic to talk about here, and that's something we call conjugates. Conjugates are not the same as in foreign language where we're talking about verbs. Instead, conjugates are useful for when we have a square root in the denominator. So let's say you have 4 over 2 plus the square root of 3. We have this square root in the denominator. Remember, we talked about last lesson, we don't like square roots in the denominator. But we can't just multiply by the square root of 3, right? We have this extra term here, and then we'd have to distribute. That's going to make our lives a mess. So instead, what we're going to do is we're going to multiply by something we call the conjugate. All the conjugate is you flip the sign in between. This one was a plus, this one was a minus. And we're going to multiply by that on the top and the bottom, because remember, what we do to the top, we have to do to the bottom. Now, why is the conjugate so cool? Let's look at this bottom two terms. Let's multiply those out. So we have 2 plus the square root of 3 times 2 minus the square root of 3. We're going to FOIL these. And what do we get? Well, 2 times 2 is going to give us 4. 2 times negative root 3 is going to be minus 2 square root 3. We have 3, or square root 3 times 2, so that's plus 2 square root 3. And then we have minus the square root of 3 times the square root of 3 is the square root of 9. Notice how our two terms here are opposite each other. So these are going to cancel each other out. And what you're left with is 4 minus the square root of 9, or 4 minus 3, which is just 1. So this is why the conjugate is useful. It allows us to go from having a square root to just having whatever we need in the bottom. Let's finish writing this out. So this becomes 4 times 2 minus the square root of 3 divided by, We just did the work for this. This comes out to be 1. And then when we distribute this in, this becomes 4 times 2, or 8, minus 4 root 3 over 1. So if you have a square root in your denominator, what are we going to do? We're going to take the conjugate, which just means we flip the terms. Conjugate means flip the sign. Right. That's it for today's lesson. Here are your practice problems. Let's have you practice. Let's have you tell me what 2 square root 8 minus 3 square root 2 is. Then I want you to multiply these together. 5 minus the square root of 3 times 1 plus the square root of 5. And then try one of those conjugate problems. I want you to simplify 3 over 5 minus the square root of 3. So go ahead and do those practice problems. Pause the video right here, and then we'll go through each of these. All right, welcome back. Let's get started. We have the square root of 8 here, which we might have to simplify. Square root of 2 definitely doesn't need simplification. Let's make our t-chart for 8. 8 is divisible by 2, getting us to 4, 2 to 2, 2 to 1. So 2 square root 8 is the same thing as 2 times 2 from here. So 4 square root of 2 minus 3 square root of 2. Then what do? We leave the radicals alone. We just work with the coefficients. 4 minus 3 leaves us with 1 square root 2. For this next one, what do we have to do? Well, we FOIL. And we get 5 times 1. 5 times square root of 5 is going to be numerators and denominators, coefficients and radicals don't mix, so it's just 5 times square root of 5. We have the minus square root of 3 times 1, so that's minus square root of 3. We have minus square root of 3 times square root of 5. That's going to be minus the square root of 15. That's our answer here. And then for this last one, we have this square root in the denominator, meaning we're going to multiply by the conjugate. We're going to flip the sign and multiply by this on top and bottom. On the top, what do we get? Well, 3 times 5 plus the square root of 3, 3 times 5 gives us 15, plus 3 times the square root of 3 is just 3 square root 3. And what are we left with on the bottom? Well, we get 5 times 5, or 25, plus 5 root 3 minus 5 root 3 minus the square root of 9. So we're left with 5 plus 3 root 3 in the top, and we have 25. The two terms in the middle are going to cancel out. So we're left with 25 minus square root of 9 is 3, meaning that our answer for this is 15 plus 3 square root 3 over 22. So those are the answers for the practice problems. If you're having questions or confusion, make sure you're emailing me or coming to office hours. That's all we have. Go ahead and get started with the homework.